How to determine determinacy of trusses. That means how to find out if a truss can be analyzed using equilibrium equations or not. If a truss can be analyzed using available equilibrium equations, then the truss is called determinate truss. If not, then the truss is called indeterminate truss. Before attempting to analyze a truss using equilibrium equations only, we should find out if that is possible or not, or if the equilibrium equations only are enough or not. So we need to find out what are the unknowns and what are the known available equations. So we need to find out what are the unknowns and what are available equations. For a truss, unknowns are external reactions. So if it is a roller, vertical reaction, and if it is a pin, vertical and horizontal reactions, and forces in each member. Every member can take either compression or tension force only, so each member has one unknown force. So the total number of unknown forces are number of reactions plus number of members. And what are the available equations? As we assume each joint of the truss is a pin, that means the joint cannot support moment. It can support vertical reaction and horizontal, which means for each joint we have two available equations. Summation of vertical force equals 0 and the other one is summation of horizontal force equals 0. So two available equations for each joint. So if we know the number of joints, let's say J is the number of joints, then number of available equations should be 2 times J. Hence, the conditions to find the determinacy of structures are if B is the number of members, R is the number of support reactions, which means B plus R is the total unknowns. The available equations are 2 times J. So if B plus R, which is unknown, is less than 2J, then the structure is unstable, the truss is unstable. If B plus R equals the available equations 2J, then it is statically determinate. And if B plus R is greater than 2J, then the truss is indeterminate, and degree of indeterminacy equals B plus R minus 2J. And even if B plus R is greater or equal to 2J, truss can be unstable if truss supports are parallel, like if there are 3 rollers instead of 1 roller and 1 pin, so 3 parallel supports, or if the reactions are concurrent, that's all the reactions meet at one point, or if some of the components form a collapsible mechanism. In that case, the truss is unstable. Let's see an example. We want to classify this truss as stable or unstable, and statically determinate or statically indeterminate. So first we need to count the members, the number of members here. So 1, 2, 3 to 19. So there are 19 members. So B equals 19. And the next one is the reactions. So for roller support, vertical reaction, and for pin support, 1 vertical and one horizontal reaction, so reaction becomes 3. And the number of joints, you can see the number of joints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So we have 11 number of joints. Now we just need to check this equation, b plus r equals to 0, and b plus r, which is 19 plus 3, should be equal to 2 times 11 if the truss is to be statically determinate, which is the case here. 22, hence the truss is statically determinate, and we can see the reactions are not parallel, and they are not concurrent as well, so you can say the truss is externally stable.